Good morning, everyone. My name is Thanankit Mami. Come from Yuprat Vichyarai School.
Good morning, everyone. My name is Vitanupa from Suvarnari Vidya School. Opponent.
Good morning, everyone. My name is Soramon Chaichan from Suvarnari Vidya School. I am reviewer.
The problem I'm going to talk about today is the problem number 3, bouncing ball. At first, I will go through the introduction about the problem and definition and observation and experiment part and conclusion and analysis. The problem is to hold a ping pong ball above the ground and release its bounce. To investigate how nature of the collision depends on amount of the liquid inside the ball and the other elevation parameters. Term and definition is I use a transparent ping pong ball with the diameter at 3.7 centimeter and mass of 1.98 gram. And the ground I use the grass surface. The nature of the collision I define it to be the height of after the first impact and the liquid inside I use water. This is my observation. At first video is the video of the empty ball that has no liquid inside. And the second video is the water-filled ball. When I observe this video, the first one will bounce higher than the water-filled ball. So I wonder what happened with the water-filled ball. At the water-filled ball, I see that when the ball hit the ground, the force that the momentum from the ball is transferred to the liquid inside. So that's affect to the nature of the collision of the ball. Approach to investigate the phenomenon and decide to use a variable to be the quantity of the water and the drop height. And then I use high-speed camera to record the phenomenon. I have two high-speed camera. The first one is a higher speed I use to record the phenomenon inside the ball. And the second one is a lower speed I use to record to record the height of its jump. And then I analyze in the tracker. About the experiment, there are the grass surface here and the scale here for tracking and ball releaser and video analysis. This is the picture that I dropped it from the 40 centimeter. At the empty ball, it can jump highest, and we can see that this trend is go like this. And the 50% ball is the lowest height for all of this. And we can see it clearly with the graph. From the graph, we can see that the 0% is the highest, and the next one is the 100%. And yes, and if we see it, but this is the graph of the height against to the time, and if we send it from the height against to the water percentage, we can see that the trend from the 0 and to the about 40% is like a downtrend here, and the 50% is lowest point, and from the 60% to the 100% it's rise up like this. And what about we drop in the different drop heights, so we can see that the trend is always the same trend like this. And this is the phenomenon inside the ball. This is a 10% water-filled ball. And this is 50% water-filled. And a 90% water-filled. At this video, the water jet occur is in a curve. We can see that jet occur like and goes up to his top side of the ball, and the 50%. When the jets occur, it doesn't same to the 10%. And what about the 90% is just occur but in a small amount. And let's analyze this. The jet formation, when we drop the ball to free fall from the drop height, before it hit the ground, the surface of the water inside the ball is like a curved shape like this, and when it hit the ground, the jet will occur. We can explain this phenomenon by use the pressure gradient when it fall down and when it hit the ball. We can assume this as a surface of water in the curved shape, and when it hit the ball, the pressure around this point is the highest pressure, and it can occur jet by the force here is go to the top and create a jet. This is the momentum transfer model. At first, I decided to use a steel ball to see the momentum transfer in the ball. We can see that when the ball hit the ground, the momentum is transferred to the steel ball inside, and it go up to hit the top side of the ball. Then if we notice that the velocity of the ball when it's hit will be increased, and we can also explain it if the inside is the water, it's just the same. When the water is hit the top side of the ball, we can see that the ball velocity will be increased too, like so. I separate the experiment result into three parts. The first part is from the 10% to the 40% part. When the ball hit the ground, the jets occur, and then the jets go to hit the top side of the ball and it make the ball jump higher but jump high but not too high. And at this point when the water is going to hit, and at the 50% and to the 60% part, the ball is the jet is also occur, but when it hit the top side of the ball, some of them will go down and it make like an opposite force to cancel each other, and then it's not make the ball jump so high. It's the lowest point at my experiment. And the last one is the 70% and to the 100% part. We can see that the jet inside is maybe it's not occur in for this condition because of there is a small space above the water to make it move and create a jet. So the jet doesn't occur, but when it fall down from the top height, it had a mass. So we can see that from this, like a 20% to the 100%, the graph will rise like it's direct. It occur if the quantity of water is bigger, it will jump higher. We can explain it by the conservation of energy to describe when the mass of the ball is increased, it make the ball jump higher. For the conclusion, the lowest point occur when the water quantity is similar to the space inside. And when the water quantity is more than the space inside the ball, it will jump higher. And when the water quantity is less than the space inside the ball, it jumps, but it's not too high. Thank you for your attention.
First, I want to ask you, you said when the mass is increased, right?
Yes.
Then the momentum will increase. Why does the height is not increase too?
What? Again, please. The momentum will increase and
When the mass of the ping pong ball is increased, and then the momentum is increased, right? Then why the height of the ping pong did not increase too?
height
From
of the
0% and 100%.
I said we can explain by the conservation of momentum for this condition, but it's a question.
Can you go to the graph? Or the picture that you show the height of the ping pong?
This
11.
11,
Yeah, slide 11.
right?
Slide number 11.
Oh. Yes.
Okay, you see that the mass of 100% is more than 0%, right?
Yes.
And why the height of the 0% is higher than the 100%?
Because the 0% there's no liquid inside, but at the 100% there's like a liquid inside. When it go to hit the ground, some energy is lost to the movement of the liquid inside. We can see it clearly, but there are also the movement of the water inside. So there's a little bit lost energy at that point.
But the 100% momentum is much higher than the 0%.
The momentum?
Yes, because the mass of 100% is more than the 0%.
Yes, but the mass.
Because the momentum is equal mass multiplied by the velocity, right? And then the first velocity is the same, and then
Could you write the equation for me?
yes. าม
The equation. Yes. The equation before the ball hit the ground and just like that's a inelastic collision. And could you write the equation for me from the this point and this point? We can see this clearly. Momentum, right?
sorry
And we can see that when it's dropped, the m is maybe it's not affect to this equation, right? If decided and assume this mass of the the empty ball, and this is the mass of the 100% ball, is there some energy loss at that point? So we can also say that the energy that lost at that point is not equal to this energy at that point because there's a water inside. Yes, it's affect to the height at some point. And I think the m does not affect in my experiment right then.
but you said the M is effect in when you present
That's from this condition to this condition we can explain because that is space of the water that move is that small space.
you want to say that only 60% and 100% that's the M have effect
Maybe yes.
okay and why did you use the grass surface
The grass surface. I didn't go to use at the grass surface because it can when we use it. I think and before I go to experiment, I test with the glass surface and like a plastic, like a floor surface, but it isn't a condition in my experiment. I think it can also to see the trend easily, like.
and what do you use to let the ball down you use your hand to let the ball down or you use what
Now I use the releaser. It's a vacuum releaser like this.
okay and then from your slide you say the momentum or the energy that's transferred to the water in the ping pong ball
Yes,
the momentum or the energy
the momentum.
or the energy
We can also say that both the momentum, and we also can say that the energy.
okay can I look to slide 12 what are these lines
These
why
lines.
is go up and then look like that. There is an error.
I think that come from the tracking error. I think so. But we only see this the collision that they define to the highest jump at the first impact, like this point. But the other points I didn't.
And what do you want to tell us about the jet? The question says you have to explain the phenomenon, right?
Explain the phenomenon.
Yes.
The question say to investigate how the nature of the collision depends on the amount of liquid. Yes, and I investigate that it's in my conclusion.
Okay. And do you know if we did not use the water, how will be the effect with this experiment? If we use another type of liquid?
Yes. In my experiment, I decided to use the glycerin too, and it's also in the same height from the glycerin. I have tried it already, and it also can bounce. And yes,
You do only one experiment, right?
in the same quantity of glycerin, but in the different height, drop height.
Okay, thank you. Okay. One thing I want to know why does he said the mass of the ping pong is increased, right? And then the momentum will increase. But why when the ball 0% hit the grass surface, and then it reflect higher than the ball that have a much more mass. I want to know like this, and I want to know what he want to say about the jet. Is the jet higher and then the ping pong ball will higher? Like this, or I want to know why that he used the grass surface. Yes, like this. Thank you.
Okay. Okay, for the reporter. For the pros of it the good point is to describe about the momentum transfer from the ball to the fluid. And one good point for the experiment is you use the releaser. And for the ball that you use to make the experiment is transparent, so we can see the effect inside. You show the video and have some kind of the steel ball, which is very interesting. But for the cons, you not exactly show about what is really the natural of the collision, how it changed, or to depend on other relevant parameters. Like you say that the height of dropping may be one of the factors. So I think it's important to illustrated how it really important. And not only that, you mainly show that jet is very important. I think other factor that should be important is the area. So you should illustrate more about this. And for your experiment, I think that some kind of the fluid that you use only water, right? So I think that you should use other type of the fluid because it will affect the adhesive force. And like you use sunlight or oil and the surface of the effect. I think that you should get as one of variable because it will affect about the energy transfer. For the discussion, one good point that he say is about the mass and the momentum. Because from the reporter, he say that if the mass increase, the momentum will increase. But from the graph, why 0% of the fluid go higher than 100%. And he explained that, and the reporter explained that the energy lost from the momentum to transfer to the fluid movement. And the opponent also suggests about the surface that why he used glass. And the reporter say that it's not his condition, but I think it's one type of the condition. And the opponent asks about the true definition of how he investigate the effect. And I think he can investigate it well enough about how it movement. And again, about the cons of the opponent, he forget to ask about the type of the fluid and about different type of the factors for the surface. Thank you for your attention.
May I ask the reviewer, the reporter, could you please move a little bit for the whiteboard? Are there anything wrong in the whiteboard?
Okay, let me see.
No, that's
Is this map?
Is there anything wrong there? Just tell me where is it, or if there nothing wrong there.
Well, because from this, I think that when...
Okay, that's enough. And how about the opponent?
I think he plus the energy loss to the momentum equation. I think he plus the energy loss to the momentum equation is not the same.
Is there anything wrong with the equation? Yes or no?
MV.
What about the reporter?
Yes. Something wrong with the equation.
Is there anything wrong with the equation? Yes or no?
I think yes.
What's wrong about it?
Because
Oh, just tell me. Just tell us. What's wrong?
because when the ball at first before the ball impact, the mass of the ball in the water is act like a one.
I have a question about for the reporter. When you put the steel ball in there, like how do you put the steel ball inside the ping pong?
I just like make a hole in the ping pong ball and then put steel ball and make
The hole?
yes.
Would the size of the hole the same for the case when you put the liquid?
Side of the hole, yes, the same. it's the same
big,
position.
big size, the hole. So how do you make sure that when you seal the ping pong, it has the same physical property as just a regular ping pong ball? How do you make sure that? Well, you need to make sure.
Make sure that it's when I release the ball, I use like a this hole and I close it, and it's the eraser. I decide to make sure that the hole is on the top of the ball. It's like it's not affect when it hit the ground.
When you take the steel ball out, right?
When I take the steel ball out.
What is that picture?
This is the ball. You asked that how I make sure that it's not affect when
That is the same as when you not just the regular ping pong ball. It has the same property.
same property.
Make sure of that.
How does the property is affect? Because it's also I think I make sure that it's stable before I drop it, and yeah.
So just maybe some simple questions. So I continue from that. Just let's say that you have a ping pong ball and you one is as brand new one, and one you make a hole in it. When you drop, what are the different? I mean, the height would be the same or different, and why? Can you answer? Maybe the reporter.
The different height of what of the
You
field?
have two balls.
Yes.
One is brand new one, another one with a hole in it. When you drop, will it come up at the same height? And why?
If we drop it, it's a little bit the difference between the height, because maybe the mass of the hole, the ball with the hole is also less than the normal ping pong ball.
Thank you. Maybe the reviewer. Same question.
Pardon question.
You have two balls. One is brand new, one is with a hole. You drop it. Will it come in the same height or not? And why?
It come in the same height. You mean one have a hole and one don't have a. Why it come in the same height?
Will it come at the same height and why?
Why it come at the same height?
Will. What do you think?
Will they? Will they come up to the same height? That's the first question.
Will it come up to the same height? One have a hole and one don't have. Maybe it depends on when you drop it. Maybe there is a reaction of.
You drop it at the same condition, at the
Same.
same height. Everything is the same, but the ball are different. One has a hole, one hasn't. So
One
which
hasn't.
one will they come up to the same height after it's bounced?
Well,
Yes or no? Yeah.
I think yes.
May I change the
Because if you say in the same condition, which means that when we release the ball and then hit the floor, it means the surface that it hit the floor and make a transfer of the momentum energy is same. So I think it at first time when it get back, I think it's same height. But maybe other time if the surface that hit is not the same, it will make the difference.
very much.